Writing classes. We've been using predefined classes from Java's API. Now we will learn to write our own classes. So chapter 4 focuses on class definitions, instance data, encapsulation, and Java modifier, method declaration, and parameter passing, and constructors. This is one of the more difficult chapters to understand, especially if you're a beginner in programming. So in the past, we've been using primitive data types, and we've been using classes, but we've been using classes from Java's API. Now we're going to write the blueprint class, which is going to define the characteristics and the behaviors of a particular class that we create. So now we have to think about managing data. Before I get into the lecture, I want to give you some examples of how this is useful to us. I created this program to create one student's final grade. So the way we're going to calculate this grade is we're going to give 15% for quizzes and discussions, 25% for assignments, 25% for midterm, and the final exam is 35%. So we're going to prompt the user for 4 grades, one for quizzes and discussions, one for assignments, one for the midterm, and one for the final exam. And then we're going to calculate that student's grade based on the input of the user. Since I'm prompting the user for data, I went ahead and imported my scanner class and I instantiated the instance of the scanner object. So the next thing I'm going to do is declare variables to hold this data, and I'm also going to declare constants for each one of these percentages. So I declared my constants for each of the percentages for the 4 different categories, and then I declared variables to hold the value that the user is going to enter, and then I made this final grade, which is going to be where our calculation goes that I'm going to output to the user. So now I'm going to prompt the user for each one of these grades, and I'm going to store that data into these variables. So I'm prompting the user for each of the 4 grades, and I'm storing each of the 4 grades into the appropriate variable. Now the next thing I want to do is I want to calculate the final grade for the course by taking each one of these categories and multiplying it to its percent, and then summing that total. I'm going to store the result into final grade. So here's my calculation for the final grade. I take what the user entered for the quiz and I multiply it to the quiz percentage. I take what he entered for assignments and I multiply it to the assignment percentage. What they entered for midterm, multiply it to the midterm percentage. Then took what they entered for their final exam, and then multiply that to the final percentage. Now I don't really need any parentheses because the way I've entered this in, the order of operations is going to do the multiplication first, and then that's going to do the summing. But sometimes it might be easier to read if I wrap the multiplications in parentheses. So I'm going to go ahead and add that in. So I added in my parentheses. Now it doesn't really do anything for my equation, but it does make it easier to look at, so we can look at this and we can tell that inside of these parentheses is where we're doing our multiplication. And after we're done with that multiplication, then we're going to add the results. So now what I want to do is display the final grade to the user. Here's my output to the user. I labeled the grades and I put each category, and then at the very bottom is where I'm printing out the final grade for the course. So let's go ahead and compile and run this program. So I'm going to enter in data for each one of these categories, and here is my result. So I'm going to go ahead and modify this program a little. Now what I want to do is I want to prompt for the student's name so I can display the name of the student and I can show them their grade as well. So I'm going to add a string variable for the student's first and last name, and then I'm going to prompt the user for the student's name, and then I'm going to include the name. Okay, so I added variables for the student's first and last name, and here I'm prompting for the user's first and last name, and then in my output I'm displaying the student's first and last name right here. So I'm going to go ahead and compile and run this program. I'm going to enter in the data, and here's the data that I entered, and here's the output. So this program was designed to calculate one student's grade for a course, and there's a lot of variables here that I had to manage. What do you think will happen if I were to change the requirement for this to be for 2 students, or maybe even 3 students, or 4 students? If I just kept going on, like 5 students. Now this program is going to become quickly unmanageable because I have to essentially do all of this again 5 times, and I'm going to have to come over here and create quiz grades for 5 students, assignment grades for 5 students, midterm grade for 5 students, final and in that final grade. Also the names of the student, I'm going to have to do that as well. Like, it's going to become unmanageable for me. So what we can do is we can write our own class to represent this student. So we can write a class for a student object, and that student is going to have a first name, a last name, a quiz grade, assignment grade, midterm, final, and a final grade. And we can even move these constants over into that class as well. So we can design what we call a blueprint for a student, and then whenever we need a student, we can just instantiate an object of that student, and we don't have to worry about managing the data inside of our driver class. So this is what we call a driver class. Any class that has the main method is essentially the interface of our program. This is where the Java virtual machine is going to start. It's going to look for the main method, and it's going to begin here. So this is essentially the interface for our user. All right, to kind of explain what I'm talking about when I'm saying we have a driver class that's going to be the interface to the user. Now here's this user here. He's using his laptop in order to interact with our program. Now this laptop has Java installed, so the Java virtual machine is what actually reads the bytecode. So when the program starts, Java is going to look for the main method, and within that main method is where we're putting our prompts to the user to enter in all this data. So this class here is what we call our driver class because it's going to have all the prompts and it's going to interact with the user. So this class here here is what's actually giving the prompts to the user to enter in his names and grades. The main method is going to display these prompts on this computer, and this user is going to type in the information into this program, and this program is going to store and act on the data. So what we're going to do is we're going to make a blueprint class to hold that data. So instead of our driver class managing the data, we're going to make a blueprint class that's going to manage this data for us. And if we actually need 2 student objects, we can use this blueprint to create 2 student objects, and this driver class over here will be able to have 2 students or 3 students, 4 students, as many students as it needs in order to run this program, however we design it. So I'm going to go ahead and create this blueprint class that we can use in order to interact with this user. So I created this class called student. I haven't put anything into this yet, but remember, our name of our class always has to match our name of our file. So I'm going to go ahead and create the name of my class, and it's identical to what we've been doing in the past, where we do public class and the name of our class. Now this class will not have a main method. It's going to actually just have variables and methods to get and set those variables. So the data that I put in here is what we call instance data. So this is the data that we're going to manage for your student. So I'm going to go ahead and create my data. So here is my data. The first thing I did is I created my class constants. Now the reason why these are called class constants is because these are associated with the class because I used the static modifier. Now the reason why I associated these only with the class is because these are constant and I don't need this data to be associated with each object. So we'll talk more about this. This might not make sense right now, but if I declare these as static, that just means these variables are only going to be set within the class and not for every instance of this class. Now I use my public modifier. So when I use my public modifier, that just means that this data is not encapsulated, and we'll talk about encapsulation in the lecture, but this means that whenever I want to access this data, I could do it directly through the class name. Now the instance data, on the other hand, I declared as private. Now what the private modifier does, it encapsulates our data, and we'll talk about encapsulation in the lecture, but what that means is there's no way for me to access this data directly through my instance of my object. So I made this drawing so I can explain what I just did in a little more detail. So here is my student class right here, right? This is the blueprint that I just created, and I just put some class constants and I just put some instance data. So we've already instantiated objects before in the past, so you should already be familiar. Whenever we use the constructor, this is my constructor in the new operator, Java's going to put this object into memory. So when Java sees student, it's going to look up the student class and it's going to look at my instructions. Now it's going to see that I have class constants. So class constants are associated with the class, but it's also going to see instance data. So when it puts this object into memory, S1, we'll just say it lives right here, but the student object in memory has its own data, like whatever variables I put for my instance data, which were the quiz, the assignment, the midterm grade, the final grade. This student object has its own data for all of those things. So here's the instance data for this object that I just put into memory. I wrote it out here, but all this data actually exists inside of memory. So when I instantiate the student object, it's going to carry its own quiz grade, assignment grade, midterm grade, final grade. Then when I instantiate student 2, it's going to be put in memory and it's going to have a copy of its own data. And the same thing for student 3. So each one of these objects in memory has its own data for all these variables. And that makes sense, right? Because, one student might have a different quiz grade than the other student. One student might do well on their final exam while the other 2 don't. So the thing that these objects in memory don't have their own copy of is the class constants, which I declared as static. Now, when I declare something as static, that just means it stays with the class. So over here, we have our percentages. And this makes sense, right? Because I don't need a copy of my percentages for each student object in memory. I'm just wasting memory if I make these associated with my instance. So this is what we call instance data because it's associated with that creation of the object in memory. And this is what we call class data because it's associated with the class. So each one of these objects in memory can look up these percentages because they're instantiated from this class, but it only exists once. It doesn't exist for each object in memory. So here's my student class once more. These are my class variables, and they're only my class variables because I declared them to be static. And this is my instance data. Now, when something's instance data, that means it's going to be associated with each object of that class. Now, one thing I want to show you is what does public and private mean. This has to do what we call encapsulation, and I'm going to go ahead and demo that to you. So here's my class I'm going to use to recreate this grade calculator. Now, what I'm going to do is instantiate a student object, and I'm going to demonstrate some of the things I just talked about. Now, it's important to keep in mind that this grade calculator will not know about this student class unless these 2 files are in the same folder. So if you're following along, make sure you put these 2 files in the same folder. And here is my declaration for my student object, and here is my instantiation of my student object. Now right here is a constructor for my student object. I don't actually have a constructor created yet, but if you don't create a constructor for your student object, Java's automatically going to default to constructor that takes no parameters. So if you don't have an existing constructor, then this is the way that you're going to instantiate an object. So I'm going to go ahead and compile. So we can see that this compiles. Now I can't really run this because I don't have any output yet. So what I'm going to do is demonstrate the class variables. So remember, when something's static, like what we did for previous classes in chapter 3, I can just call those through the class name. Like the math class has the pi and the natural number e, and I just called those through the class name. I'm going to do the same thing for the percentages that I created over here. So here are my output statements. I'm calling static variables, so I just called them through the class name. Now, since these are static, I don't need an instance in order to access this data. And since I made it public, that means it's not encapsulated within this student object. So I'm going to go ahead and compile and run this program. And here's my output. I'm simply just displaying the percentages that I have in my student class. Now let's see what happens when we make these variables private. I made these variables private. What this is going to do, it's going to change the visibility. And by visibility, I mean we can only see this data now within this student class. We won't be able to see it outside of the student class. So now if I were to compile and run, I will get a compilation error. And you can see that Java noticed that these variables I'm trying to access are private. So Java's telling me I don't have access to that data. Since I declared these constants using the final modifier, that means this data can never be changed. It's okay to make these constants public because there's no way for this data to actually change. Now let's see what happens if I try to access any of these variables. Now notice that these are private. So I made this output to test the visibility of the quiz grade. So this quiz grade is this variable over here in my student class. Now notice I'm trying to access this data through my student class and not through the actual instance of my object. So I'm going to compile, and here's the error that I got from Java. Java's telling me that that data is private. So I'm going to go ahead and make it public, and let's see what happens. So I changed all these variables to public. I'm going to come back over here and recompile, and I get another error. Now Java's telling me that that variable is not static. I'm trying to access that data through the class name. That is what we call instance data. So the only way for me to access that data is through an instance of my object. So I need to use my object reference variable to this student object. So I'm going to change my program. So now I'm trying to access this data through the object reference variable. I'm going to go ahead and compile and run. And you can see that I was successful in doing so. Because this is declared as public, I can access this data through an instance of the student object. But this violates encapsulation. The reason this violates encapsulation is because the whole purpose of creating this blueprint class is to protect my data. So now that I have access to this data through the object reference variable, I can change quiz grade in my driver class to whatever value I want. So I'm going to go ahead and do that. Here I'm referencing the quiz grade through the object reference variable, and I'm assigning the quiz grade to be 10,000. Now 10,000 doesn't make sense for a quiz grade, but I'm doing that anyway, and I'm going to go ahead and print out the results. And here is my output. So when I instantiate a student object, Java is going to look at this constructor and it's going to go to my blueprint. And in my blueprint, I'm going to define how my student is going to behave. Now, the whole purpose of making this blueprint is to manage data for my student. So when this object is in memory, this blueprint is going to define how this object is going to behave. So the idea of encapsulation is that this object in memory is going to protect its data from being set to something that doesn't make sense. So the idea of encapsulation is this object in memory is going to use this blueprint to protect its data. Now, when I say protect its data, it's not going to allow direct access to its variables, and it's going to set up methods or what we call services to get and to change that data. Now, the reason why we do this, it helps protect data integrity so that we can set rules on the range of our quiz grade to be within 0 and 100, or maybe 110, depending if there's bonus questions. But setting it to 10,000 makes absolutely no sense. Or setting it to a negative value makes absolutely no sense. So we control the way this object behaves in memory by how we define our blueprint and what we specify the access modifiers to be. Now, when I say access modifiers, I mean what data is going to be private, what data is going to be public, what methods are going to be private, what methods are going to be public. So here's my student object from memory. How this object behaves is how I define this blueprint over here. Now, when I declared this quiz variable to be public, I basically gave direct access to this data. But this violates what we call encapsulation, and it's actually a poor programming practice. The way to properly do this is to set a method to get and set this data so we can better protect our data. So typically when you see drawings and diagrams of classes, you're going to see something that looks like this, like a little lollipop. Now what this is actually just specifying an interface to the student object. This is what we call our services. So what we can do is we can make this data here private. So the only way you can access this data is inside of the student object. But we can set up public methods to get and set this data. So when you get the data, we can make a public method that is just simply going to pass out this data. When you want to set or change a quiz grade, we can make a service to set that grade. Now within this setter method, we can actually do some type of filtering so that we don't set it to something that doesn't make sense. Now unfortunately, we're not going to learn how to use if statements until chapter 5, but I'm going to go ahead and start sprinkling it in so that our blueprint classes can make a little more sense.